The circuit below shows a battery of EMF E, internal resistance R, external resistor R, and so on and so on and so on. And you have to use that form. You try to prove that formula for small r. So let's draw the circuit here. So here is E, here is small r, then here is big R, and my voltmeter tells me the voltage here is V. So I know, what do I know? I definitely know the V and the big R. Okay. Anyways, we want to try and get that formula there. So let's write down a couple of rules and see what we can do. So we can use Ohm's law here, and we get V equals IR. Okay? That's not going to be too helpful for the moment. Let's use Kirchhoff's rule. So we have E minus this voltage here, which we know is V. But then if you look at this and use Ohm's law for this one, you could say, I'll call it voltage for this, for the small r, will also be the same I times the small r. So we can get E minus V minus the other voltage, that should equal 0. Now if you look at his formula, he has big V and big E in it, but we don't have this in it. So maybe we should try change this. We could say E minus V minus I or equals 0. And again, if you look at his formula, he doesn't have I in it. So then maybe we can change the I by using this one. I is V over R. So we get E minus V minus I times V over R times small r. Sorry, no I there. I was replaced by V over R equals 0. Now, I think that will do it. If we rewrite it, we get E, I want the small r, E minus V equals V over R, small r. So then dividing E minus V over big V times big R, that will be the small r. Okay. Okay, now, B part. Stop fighting. What's wrong?
Can I see the last one?
Yeah. So, B part. You have two lamps of a 60 and a 40, and they're connected in series to a 240 volt supply. Draw this circuit. Okay, so that's just one mark. So let's just draw it like this. So there's 240 volts, and then here is one lamp, and then here is another lamp, and this lamp here is 60 watts, and then this lamp here would say is the 40 watts. Okay, so that's just the one mark to draw the diagram. By the way, guys, 240. Hey, 240 is obviously going to be one of these on the wall. So that's usually the symbol we use for that, okay? In fact, sometimes people put this here as well with it. Okay. So we have this table we need to complete. Oops. So this is A, this is B. So we have 4 things to find. Oops. So the first one here is the resistance. Then the second one here is the current. Then the voltage. And then the power. Okay. So, resistance. Well, I'll call this one the A, and then this one here the B. Yeah, A and B. So what formula do we have for resistance? Well, I should point out something first, okay? I think I might have said this last time. I don't remember. Just because a lamp is a 60 watt lamp, that doesn't mean that there be 60 watts of light coming out of it. Right? In fact, that doesn't even mean it will use 60 watts. It only is designed to use 60 watts. If you don't give it enough power, then it won't use the 60 watts. Okay? Now, what formulas do we have for power? Well, we P equal I squared R. But just like in the last question, we want the or, just like what I did a few minutes ago. And we have the P, but we don't have the I. So it's a little bit strange for me. I remember doing this last time as well. I almost feel like, Andy, look up please. I almost feel like these should have been the other way around. That it would have been easier to get the current first. But anyways, it doesn't matter. We'll do it the order they want. Yeah.
Can we use P equals I squared R and then substitute the R V equals IR?
Yep, that's what I'm going to do. So we have V equals I R. So the I equals V over R. So we put that inside here. And we get P equals I squared R. Sorry, and the I squared. P equals V over R squared R. So we get P equals V squared over R. So we get R equals V squared over P.
The P, so total.
I'm doing it for each one. Oh yeah, I also have to say something here now as well.
The voltage is.
Hang on, don't confuse me now. Don't confuse me. Yes, I have to say something with the voltage.
Is it 240 for both?
Yes, that's what I have to say. If I just zoom out for a moment, just for there's something which I think I mentioned to you. I can't remember, but this is the first time this has happened. This is an AC supply. What's the difference between AC and DC? Do you remember? Did we do AC and DC? I think we did. Are you sure? I think we did. I mentioned it. No? Okay. Well, I'm sorry if I didn't mention it. I thought I mentioned it. It's still possible that maybe I did mention it. Everything we've been doing so far is called DC. Battery, circuit, whatever, DC. In fact, this here is an AC supply, not a DC supply. What's the difference between AC and DC? The only difference you need to know is this. DC, the current moves in one direction only. Whereas with AC, the current is moving back and forth. So it'll move here, and then later it will switch to here, and then it will switch back to here. Okay? So the voltage here is changing, the current is changing its direction, and usually it changes its direction every 0.02 seconds. So for 0.02 seconds it'll be going this way, heading through the B first, and then later it swaps and then it'll be heading this way first. Okay? So if it was DC, the voltages would definitely be different, because when it hits the first one it drops before it gets to the second one. But because it keeps changing its direction, both of them share the same amount of time as being the first one. So for one moment this will be first and this will be second, and then it'll very quickly switch the other way, so this will be first and this will be second. So the voltages will be the same for both. Yeah? And the total voltage is 240. So actually, I'm sorry, I don't know if that means if I should put each one as 120 instead of 240. Let me check the marking scheme. Oh, for goodness sake. We'll leave that for a moment. Let me just check the marking scheme here. Now, after I've explained it to you, I do wonder if it should be 120 and 120 each. This is number 9. So if this is number 9, it'll be about maybe 3 years ago. So we're looking for a diagram and a box. Diagram and a box. Diagram, box. Nope. Diagram, box. Nope. There we go. So that is number 4.
Same answer. Just over.
Yeah, same answer?
Yes, it's 240.
Okay. So the lesson that we've learned is when you have an AC supply, it'll be the same voltage in each resistor, each bulb, okay? Oh, so what did I have previously here? 960 and what, well, it was the same, wasn't it? 1440. Okay. Now, next one is the current. I don't know if you can see that. What formula can I use to get the current, do you think? I have the resistance now. Well, I think I'll use this formula right here, actually. R is P over I squared. So P over R. So the I would be square root P over R. Or you're right, Andy, I could also use Ohm's law. Let's see if they both give the same answer. So square root P, which is 60, over R, which is 960. So that's 0.25, whereas the other one would be square root 140 over 1440. Sorry, did I type something in wrong here? I feel like I did. Square root 60, which is the power, over the R, which is 960. No, okay. Now, I don't know, let's check if we get the same answer using Ohm's law. So Ohm's law said V equals IR. We know the I, we know the R. So actually if I just multiply them, I get the V. Wait, hang on. V? What am I doing? Sorry. Something's not quite right. Something's not quite right at all. Wait, sorry, I'm being stupid. Nobody corrected me. This makes me worried. Look, sorry, I'm being a bit dense. The I has to be the same for both. Remember, if 1 coulomb goes into one, and then it leaves it, and then it must go into the second one. So, wait, please, don't interrupt. I don't want to be confused again. So the I must be the same for both. Okay? So we have to look at the total circuit. So the total resistance will be 960 plus 1440. So the total resistance is 2400. Okay. So what can I use to get the current? Well, maybe V equals IR. So V is 240 for the total. V equals IR. So 240 divided by 2400, that's 0.1. So the current is 0.1 in each. Yeah.
Because the total current should be 400. Because both of them have 240, 200.
The total current?
Voltage.
Yeah. Why is the voltage not what?
480 should be.
You're talking about for the next step, or what? Oh, what I did here. No, because the total voltage is 240 from the power supply.
But both of them supply 240.
But if I put these together as one, it would look like this. There's a 240 here, and then there's a, what was it, 2,400 here. So it's like it's one, and it's like it's 240 going through it. You see, the problem is, it's because it's AC, it's more confusing. It's 240 in total.
So this way also 240. So always 240.
Always 240, yeah. But it looks a bit strange now because he says, what's the voltage? Yeah, but that's the voltage if, how can I explain this now? Okay, I know what I'll do to explain it. Please look up. I don't want to confuse you, so listen carefully, alright? If I say that this lamp here is 60 watts and it's connected to a 240 supply, and I have another lamp here which is 40 watts, it's also connected to 240 supply, I know the 240 will go both directions. Okay? But remember what I said at the start. It's not like actual 60 watts will come out here, and it's not like an actual 40 watts will come out here. So the 60 and the 40 is not the same for each of them. Oh, I mean, it's not always going to be 60 and 40. Like, for example, if that light there is 100 watts, it doesn't mean it will actually use 100 watts, because it'll only do 100 watts if you give it enough power. So what will be the same? Well, the thing that's always the same for the light is its resistance. So when you calculate the resistance from each, you assume 240, because that's what it'd be doing if it was operating normally. So maybe it was wrong of me to say, oh, it's like it's 240 in each. Maybe it's a bit clearer to say it like this. First you picture it by itself with 240, and then you picture it by itself with 240, and these give you the ores in each, and you go back and put it into here. And the ores will not change because it's still the same light bulb. But the voltage will actually be different in each. It won't be actually, when it's actually switched on, it won't be 240 in each. And the reason for that is because the I will be the same for both, right? So if the powers are different, P1 does not equal P2. What's a formula for power? IV. So I1 V1 does not equal I2 V2. But remember I said the I's are the same. So it should be the case that the voltages are different if the power ratings are different. So yes, I know this is quite confusing, but for this one here, it's like you assume 240 so that you can get the ore.
When I use P equals IV,
Yeah.
V is 600.
Well, P equals IV.
Yeah.
I think maybe V equals IOR to get the V here.
Well, shouldn't it be the same? P equals IV or V equals IR?
No, because in fact that P there is how much power it actually does, and it might not do the 60, is what I'm saying. To get the voltage though, because the ore will be the same no matter what. If it's using a lot of power or small power, it will have the same resistance inside of it. And we know the I. So if I multiply these, I get 96 and 144. And what's great is you'll notice that they add 240. Now, NP, if you use power equals IV, if you multiply these, you get 9.6 and 14.4. So what you'll notice is, although it's rated at 60 watts, will actually only do 9.6. And although it's rated at 40 watts, it'll actually only do 14.4. We'll double check that there. Yes. So which lamp will be brighter, A or B? B. B will be brightest. Yeah. 10 now.